We're at GoToMath.com. Click on the algebra. Let's go down to operations with radical expressions, and we're going to be looking at 1.2. 1.2 here. All right. So we have 6 times the square root of 3x minus 2 times the square root of 3x. So remember, we want to take a look at our like radicals. The square root of 3x, obviously the square root of 3x here are like radicals. They both have the same index number, which is 2, and their radicand is both 3x. We can actually look at this a couple different ways. Since we have these are like radicals, we can look at their coefficients and just add their coefficients, and so we get 4 times the square root of 3x. And another way of doing this is we can factor out the 3x, and we'd have 6 minus 2. Now, if you distributed the 3x across, okay, we should get back what we started with here. And of course, 6 minus 2 is 4. All right. Okay. Looking at another one here, so we have 2 times the square root of 5x, and then plus 3 times the square root of 5x. So as soon as I get this done right, and you need to try to work this out, simplify this down, and then compare your answer with mine. Minus 8 square roots of y. Right. So pause the video, try working that out. Okay, well, let's look here. We got square root of 5x, square root of 5x. So we'll be able to add these two together. So this would be 5 times the square root of 5x. And then we have 2y minus 8y. So that's going to give us minus 6y, yeah. 6y. Okay. Now you notice we have 2 radicals here with both the same index number, but their radicands are different. And so therefore we cannot just add those together. So that's as far as we're going to be able to get with those. All right. Okay, let's take a look at, we got time for another one here. Take a look at another one here at GoToMath.com. That's GoToMath.com. Alright, minus 7x 3 roots of 10y. So as you can see here, we both have the same index number and the same radicand. And also, it should be noted that this is to the first power and this is to the first power. In other words, these are like terms also. Okay, so that's kind of important here. So if these are like terms, then we can just go ahead and add them together. So as you can see, these both must not just be the like radicals, but we also, this variable must be like this one. Alright. So another way of looking at this, we could have 3 roots of 10y, and if we were to factor that out, okay, these are both like terms right here, so we end up with, and I'm going to bring these actually out front, so that's going to be a negative 6x negative 6x, and then 3 roots of 10y. Okay. Alright, I think we got time for another one here at GoToMath.com. So we have 4x squared, 3 roots of 7x minus 2x squared, and then 3 roots of 7x. Okay. So we got 4 minus 2, and that's going to make that 2x squared. We're able to do that because x squared, these are like terms also, just like in the previous problem. Okay, just like in the previous problem. And then of course we've got 3 roots of 7x as our final. Okay. You could also treat this by factoring out the 3 roots of 7x out of both terms and treat it just like we did up here, and of course we'd end up with the same answer. So we're over here at gotomath.com getting it worked out. That was 2.1, and we're going to be looking at 2.2. See you in the next problem.